Hello. Today I want to talk about natural milestones in software. This is from the book Dynamics of Software Development by Jim McCarthy. Book came out in 1995, and so it seems like ancient history, but I still hold that the book is filled with tons of excellent advice that's actually timeless. Some of it's dated and no longer applicable, but lots of it will hold true, I think, forever. One of those things that I actually think it has a large sort of value to it is this notion that he talks about that software projects, I would say probably projects in general, go through some natural stages as we work on them. This has been really true, I find, in 342, because we're almost always starting with projects that have never been done before. In other words, especially, there's no code written yet. So we're starting from scratch on these projects. Likewise, there's an end. There's a very solid end to them, the end of the course. And so we end up with a project basically going through this progression, even though we're using Scrum and we're having these sprints and we're iterating and we're going and having our sprint reviews and so forth and so on. So while an established product, if we had an established product, and let's say the team's been working on it for a year, it's been out there with customers or who knows what, and yes, the Scrum team is continually, each sprint, they're working with the product owner, determining what next to work on to get into the product by the end of the next sprint, or what work to work on. That's the modern steady state. And there may not be quite as much of this notion of going through these natural milestones because you've sort of reached the point where the product is stable and we're just adding new things. But maybe with regard to adding a whole new set of features, or maybe the product owner desires a complete remodel, you might end up finding yourself going through this cycle again. So let's find out what this cycle really is. So the first natural milestone that he has is the design stabilizes. All right, and what does he really mean by this? Well, the way I sort of translate that into the language we've been using is that shared understanding about what the features are or really are comes about. So is achieved. So initially, remember, we talk about this idea that we go and we talk with the customer. The customer gives us this problem. We come up with some ideas. Maybe the customer had some ideas. And every person on the team, and the customer as well, actually has a different idea about what we mean by this feature or something along those lines. And it's not until we start making the drawings, our lo-fi mock-ups, getting into some of the development maybe, that we actually go, now we know what you meant by the food angle, whatever, feature. Yes, you meant that, we thought this, or I thought this, and you meant that. Oh, no. Now that I see it drawn out, and we've talked about it, I get it. This is what it is. So it takes some time to reach this stage. Usually you'll see, there will be projects, and especially if you're going to be dealing with fourth year design projects, or anytime you're going to start something new, people are going to be talking about things, lots of cool ideas. But it's not until you start making it concrete and start writing some of it down and working on those whiteboards and design drawings and things like that, until you start to achieve that shared understanding, there's you're just all seeing something else. You're seeing what you want to see. So this is the first step of the project that's really clear, because you start over here, start up there where we all envision something different. Boom, once we all see the same thing, that you've hit that milestone then. Well, he goes further on the next milestone, which is the deliverables become crisp. And you're like, well, wait a minute. If we have shared understanding, what is this? I think this really is, now we have firm notions of what features exactly must and must not do. You know, you've probably seen this as you've gone through the project. Yeah, we all understood the features this. You got your shared understanding. But maybe we didn't understand that, you know what, yes, we need this many decimal places shown. Or no, when this is the case, we show, not applicable. Or, no, the message really needs to be this. The button needs to look like that. These are the fine details that we've avoided up until this point. And now we really have this. We really know exactly, because a lot of this comes about between, you're writing the code and someone says, well, that's not right. That's not the way we want it. Or the customer tells you that's not the way I really want it. Okay. And we've got a little bit of tension in play here, because the developer had an understanding or implemented it some way within the constraints of the shared understanding. No one's saying it's not within the shared understanding. But now it's like, I want a different word there. I want this changed. I want this color, okay. These things start to become very concrete. Like, we're really defining what things are, and we really know what exactly it's going to have to be or not have to be. Often that goes along with, geez, there's a lot more work here than I originally thought, because I thought we had understood exactly what was necessary. No, not quite. All right, but things become crisp now. So we go through that stage. Now, I feel that, basically sprint 1 and maybe 2 is that first stage where the design is stabilizing. Some of the crispness is happening in sprint 2, or happens at the sprint 2 review. The client is, you finally show them enough. The client is able to start giving some really not like this type of feedback, and that's where things start to become crisp for you. So it's a progression over it. I see this in 342 over sort of the first 2 sprints. Maybe in the midst of sprint 3 things are becoming crisp, but they really should probably already. It's usually often at the end of sprint 2 at that review that things are, I feel, are pretty doggone crisp. There might still be some things to resolve, but we have a real good sense of some of this stuff. Certainly they'll be crisp by the end of sprint 3. Milestone 3, which is the team realizes the true extent of effort required to finish. And this is sort of where we start to understand for what the client sort of expects to be done, now that we really understand things, we understand a lot more about actually the true sizes of all these stories, because we're having to go back and create new versions of those stories. Often we're having to fix them up. These are new requests. We're starting to understand any of the other feature requests that are coming in. And we can make this sort of estimate out to the end of certain dates that is much more accurate than we used to have. We really have, it's really going to be this much work to get that story done. We thought we kind of had it done. We really didn't. Now we really know, this, hopefully this isn't the way you would think it wouldn't. You think you'd have a story done, you'd have a story done. But the reality is it seems the story goes to the client, doesn't actually pass their acceptance criteria because we had the wrong acceptance criteria. We didn't truly understand the acceptance criteria. So new acceptance criteria basically gets written, which is the equivalent of saying we have some new stories. And we're really, or modifications to the story. And so that we have to keep working on that story. So our original estimate was actually wrong. Now we really understand it. It wasn't a 2-point story. It was a 2 plus a 2-point, really is a 4-point or larger story by the time that we're done working on it. So yeah, this is where you realize often that there's lots more to do to satisfy the client on a feature. You thought you kind of had it done, but you really didn't. Part of what is also happening at this stage is that you're starting to see that there's lots of edge and corner cases to handle that you very well may not have already handled already. Now, if you're a deeply experienced expert engineer, 10 years into 20 years into your career, maybe this wouldn't crop up. But you're new. You didn't foresee these things. And so, there's that stuff still to do. Effectively, again, as I just said, the stories, you discover them are bigger than you had actually planned or envisioned when you first started working on them. One of the phenomena that I certainly experienced going off into the workforce was, and my education was a bit different than yours. I had no explicit course on software engineering like this at all. I'd never worked on a team to develop software. That's where the state of things were for computer science education. Certainly software engineering often wasn't even taught as a degree in the time that I was a student. So one of the things that happened was when I was in school, you do an assignment. So you're given a specification basically by the instructor. You work on the assignment. You really think you have it good, and you turn it in, and you get some mark back. So you're done. Even if there's some mistakes, you're done. What I found, and I talked with lots of other people about this at the time, was that we were all other new graduates. We basically learned, that what we did in school, was this classic sort of thing where, it was 80% of the project, but that 80% of the project is really only about 20% of the time. The remaining 20% of the project takes 80% of the time. It's this whole weird thing, and you're like, the amount of effort needed to really get things truly done is a lot more than we're often used to. Okay, you can get something basically that's 80% done really pretty quickly. To get it 100% done takes a gigantic amount of time. It's that all those small things at the end just seem to, there's so many more of them than you had originally envisioned and thought about, and they eat up a gigantic amount of time. And that's one of the differences between, again, school and reality. You're seeing a lot of that on co-op. Hopefully you're seeing some of that in this course, because you're learning things are not really done by the client's expectations. What you thought might have been done is not done yet. So that's one of the big things. So I really feel that this absolutely is, this realization sets in throughout sort of sprint 3 for MSci 342. It's like, geez, we start to actually pay attention to our bugs. We realize there's all of these issues and those issues, and oh, what should we really do? And yeah, that you get hit with that. The fourth milestone that you sort of have, which is, this is the point where the design is shrunk, or resources are added, or the schedule slips. Now this is written from sort of a class, and then he says, then he goes, or all three. This is written in terms of sort of the classic mentality of waterfall. But just because we're not using waterfall doesn't mean we're devoid from the natural order of the world, where the business side expects certain functionality done by a certain date. We want, I just think of probably the biggest form of traditional, that's close to the traditional software that you have, are video games. These things, we know people buy them, for example, for holiday presents, Christmas time. Got to get the game out in time for people to spend their money on it, to give it to, the children, or buy it for yourself. So, and there's numerous cases of all sorts of these products where people might end up rushing them to market before they're ready because of the date. Those are examples of software engineering gone bad. So this still happens even in our modern world of agile delivery and everything. It's a little different, but it does happen. So again, what's really, we come back to this triangle. Some call it the iron triangle, other like a project triangle. There's different versions of it. The one I was taught and I use is, at one corner we have scope and quality. Another, we have the time for the project. And the other are resources, which in software invariably really is all about people. We usually don't need money or more computers or things like that. So again, these are all interconnected. They're constrained. Usually the idea is something's fixed, which means you can only manipulate the other ones. Okay, but the reality is that what he's got here, design is shrunk. This is a change in scope. We never want to actually be manipulating quality. That's when things, we have disasters. That's when people are reporting, oh my gosh, I bought this game for $80 and it's filled with bugs and it's useless. Okay, no, you don't want that to happen. So let's say quality isn't something we're going to manipulate. So scope, the design is shrunk. In agile methods, so whether we're doing Scrum or Kanban, so it's natural for agile methods to handle this, because you kind of would say they automatically scope themselves. We work very carefully to do our features in priority order. So we're getting the most value done in the given amount of time that we have. So that's true. But I want to note that even under the agile, you may need to come up with new, simpler stories. So your client might not agree, your product owner might not agree to cut stories. And you're like, oh, those are only stories we're able to get done by the ship date, by the time you want to release and tell the public. And client's like, I need them all. And you're like, you can't have them all. They're not going to be done in time. That's when you need to change what the stories mean. So you need to say, oh yeah, so we've got, let's say it's a video game and we have, let's say it's a driving game. Oh, we have so many cars. And we let, well, you're not going to cut the notion of the cars, but you might cut the number of the cars that are available to play with. You might change the number of gestures available, but you still have gestures or something along those lines. There's, it still has to have the stuff the product owner wants. So you still might have to come in to negotiate and talk about, well, how are we going to change the stories so that they're doable in the amount of time? That's another way of cutting scope, rather than just sort of, we don't do certain sets of stories. That's the easy way. And that's what the agile methods already handle, but they don't automatically handle this. This requires the same traditional notion of going and working with the product owner and saying, what are we going to do? How are we going to get this all done in time? So you have to refigure out your stories. You go back to that user story map, your release planning, and you discuss and you figure and you start breaking stories, changing them, and so forth and so on, such that you actually think that you might get things done in time. Again, time, that's where you talk about a schedule slip. You actually do convince the product owner, give us an extra month. That's a slip in the schedule. Sometimes that might be the solution. Again, if they're like, nope, we cannot reduce the scope at all in any way, shape, or form, you got to push out the time probably. That's sort of you push back on the product owner. And you work within this and you talk about that. Well, if we're not going to change that, are we going to change this one? And if they're like, no, we refuse to change the deliverable as well, then the question often comes into dealing with people. So if you have time to bring people up, you might add more people. And I would say you're going to need your project to be running in a Kanban-ish fashion. Scrum by its very nature is I have these little teams. Scrum is not very interested in you taking your 2-pizza team to a 4-pizza team to a 20-pizza team. I mean, imagine your stand-ups filled with all these people giving tons of status and commotion. Like the communication will overload everyone. There's too much communication in that style. So you might go to a Scrum of Scrums, where yes, we still have a bunch of Scrum teams, but we've got the product owners and the Scrum masters from each of those teams meeting and conversing and trying to communicate across the Scrum teams. I think that's probably suboptimal compared to running a Kanban style setup. It'd be far better to be able to have everyone in that project room, be able to see the whole project on the board, have everyone knowledgeable about what's going on, but still have an efficient communication process. I think that would be much preferable. Certainly, you're not going to put 1,000 people, though, in a room. So for even larger scale projects, there's going to be a lot more. There's going to be some sort of hierarchy and communication between teams. And that's where dividing the project up into sort of very concrete components, very carefully defining the interfaces between those components would be really, really critical so that people can work more independently and have dealt with the integration issues between the parts that they're putting together. So there's a lot of stuff there. But you hit this point. In 342, basically at the end of sprint 3, as you go into sprint 4 planning, most teams are going to realize, wait a minute, how are we going to get it all done? Especially given we want to keep our quality high. So we're not going to let that slip. What are we going to do? You know, I've instructed you to be careful about how much effort you do on your last sprint so that you don't overwork yourselves. So that's going to limit the amount of time that you really have for it. So what are you going to do? You might need to be having a real good conversation with your client about what is feasible and what really is the most important stuff to have done, given that quality has to stay high. And you might be behind on your quality. You might have some sort of technical debt, so to speak, necessary there to catch up on. Lurking bugs and problems that you aren't aware of. All right. So that basically gets us from in 342 down to the end of sprint 3. You know, this is sort of the natural milestone feeling there. Now we're heading into the final stretch, and we've got two final milestones in the traditional natural milestones. These are definitely, I feel, a bit different for the modern world, but they're good to know about because you might be on a regular team someday. They're also good to know about from the mentality that that sort of the truth of the matter comes, especially in situations where you have your quality aspects of your project aren't where you expect them to be. You're not actually testing things as well as you really should be. What does this mean? Well, this means all coding stops. What does it mean to be all coding stops? What this means is we call this you are feature complete, or you call yourselves code complete. This is the sense that when the developer says, I have developed that story. You know, look, it's done. I kind of think of this as the notion of a traditional course assignment. Yes, it's done. I turned it in. I believe I got it right. The problem is there's bugs and other issues and problems in there. But that's different than a blank sheet of paper. You know, that's different than I haven't written any code. Once you've written the code and you think you have it done, you can say, yes, I don't feel like I need to write new code. If it works, we're done with the project. That's code feature complete, okay? That's a traditional sense. This really shouldn't be going on in our agile methodologies. This is really much more a notion of we do development and then we're going to hand it off to test. So this is sort of the waterfall sense. Yeah, we've written all the code. Now it's time to start testing. Hopefully our modern practices are beyond that and we don't need that. But I happen to know that a lot of students in 342, we still haven't got our testing and our quality methodology fully up to speed. And we're still letting bugs slip through. So there does come a time, though, when people are, the way to think about this is there's no new stories, you know. So from an agile, this is, no new stories. we actually, on a micro scale, it would happen within the sprint. But on this project scale, it's that point probably during sprint 4 where you're like, yeah, we actually, all the stories that we said we thought we were gonna do, they're really actually, we believe we've got them all coded and merged and everything's in the product. Oh, we might still have bugs though. Okay. So you might still be going through this sort of notion, even in a Scrum world, if your quality isn't high enough. Then you go to the natural milestone number 6. This is the last natural milestone. The product enters and exits a debug stabilization phase. So this is when, we're finding all the bugs in our product because we failed to find them while we were coding. We failed to find them before we merged those PRs. We didn't actually do our job correctly. It happens. We've put buggy code into the product. It's done. We wrote it. We thought it was done, but we realized through more work that we've got mistakes, we've got problems. So the team goes to a world now where they're only fixing bugs. And they're going to be careful not to add new bugs. And just to be clear, there's no new features being added to the system at all. If you were to add a new feature, you've gone backwards. You really hadn't reached this milestone, so to speak, okay? And again, this 5 and 6, this is representing the tail end of a waterfall process. In 342, again, because we've got that hard deliverable end of sprint 4, it has a natural feeling that you might actually be doing some of this as well, as opposed to just continuing to pump things out with your 4 sprints. If you had been doing your agile perfectly and always making sure that your code was tip-top in shape and you didn't have sort of a debt of quality, now absolutely, you just go ahead and do another sprint 4. For teams though that have quality that is not really where it should be, your sprint 4 is going to be a little bit more like 5 and 6 there. Okay. So, all right. So 5 and 6 are also together what is known as, by McCarthy, as the end game of a software project. So this happens before its official release. And again, mentioning this is the big notion is this is the phase where we stop adding new features. Because we realize that we have a debt on quality or technical issues that we need to catch up on, really. We're behind, and we're going to tell everyone to stop putting in new code because we need to fix up all the mess that we've put in there. One last time I'll say it, if you've done it right, you won't have this end game. Chances are, though, all projects probably have it to some shape or form because it's really hard to be perfect in your quality. Okay. So what do you do in the end game besides not put in new features? Well, this is where you go to a phase he calls you need to triage ruthlessly. And this is very, you'll see this on every waterfall project. We say we code complete. Now what we do is we're finding bugs and we're logging all the bugs. Okay, so you're gonna have your hunt for bugs. You got QA testing working on it. Developers are going to work on it as well. You're going to run bug bashes where all of us get together and we try to find bugs. And when the bugs are found, we are extremely careful to log all bugs. Okay, so you could put this in some sort of issue tracker. You might have something known as bug tracking. You might, if you're using agile methods, just add these as tasks to the Scrum board or your Kanban board. These are things that need to get fixed. We're going to put them in as work items. That's what you should be doing in 342. Okay, so you put them all in there. This is really important, this step. It doesn't do you any good to find bugs if you don't record them, because you got to come back to them and keep track of them to get rid of them. So the real reality is anytime you're using your software and you discover that there's a bug, you need to log it. You don't go, oh yeah, I'll remember to fix that someday. You always immediately go, I gotta write that down. I just found something that we have to fix. All right. So chances are you have a limited amount of time. So if you're limited by time, you're going to kill the most important bugs. Probably not kill some of them. If you're going to send a space probe to Mars, though, I know you've got a launch date, but I sure hope you have a chance to fix all known bugs. You probably really don't want to ship it with any bugs that you know about. Either ways, what are you going to do? How do you decide what's most important bug-wise? And this is the triage aspect. So triage is we've got all these bugs, we have a limited amount of time. Which ones are we really going to fix? And which ones might we ignore? So usually when we log bugs in traditional bug trackers, we log a notion of their severity. Okay. So this is, often this is loss of resources. Again, be careful about these are going to cause any life, loss of data, etc. There's all these sort of resources, time, life. How bad is it? Okay, how bad is the bug? What's the consequences of this bug if it actually happens to someone? There might be a separate notion that you keep of significance. I often think the best way to think about this example of significance is it might just be embarrassing. So you might have something in there, it's a spelling error. Its severity to the user for loss of data, resources, life is non-existent. They will not suffer to see a misspelling other than but you will be embarrassed and it'll hurt this customer relationship, okay? So you might need to take significance into consideration. So it might be low severity but high significance. What's the extent of this bug? So this is sort of the percent of the customers to experience it. How widely affecting is it going to be? Is everyone going to see this? Is it only the rarest circumstances that are going to lead to this problem? We estimate that 0.001% of our customers will ever experience this bug. Well, okay, that's pretty low probability of it. But by the way, if it's a severe thing, it still might need to be fixed before you release things. A big question often people will ask at least management will want to know in trying to triage things is, will fixing it likely break something else? It might be that the way it is written allows tons of other code to work properly. And everything is dependent upon it working as it does, and the way it works, it has a problem. So if we fix it, we might actually break tons of other things. It's at the core. Everything depends upon it. This is really, really an important piece of code. Everything else is working, but there's a part of this that's broken. Oh, geez, if we mess with it, what's going to happen? Usually people will want to know how long is it going to take to fix as well. You know, if it's not the same, some big bugs could be a huge amount of work to fix. So in triaging, you might need to figure that out because it's going to eat up resources, which limits the amount of bugs that you can get actually fixed. How hard is it to confirm the fix? So if we can't have a good way of verifying we've actually fixed it, so this might be something that's like, we saw this once during testing. We got this error message, but we don't know how to recreate it. We've never been able to recreate the bug. We know it exists, but we don't really know how to make it happen again. Oh. So is it going to be futile to try to fix it because we can't ever confirm it? Maybe it rarely happens, you know. My experience has tended to be that that rare thing that you see once and you have trouble replicating, that'll be the thing that thousands of people tell you you have a bug about. They will all end up finding it before you know it. And then you will really feel sorry about this. All right, so that's you would likely find in a scenario like this, you've got your bug database, it's filled with bugs. There's so many weeks until we need to release the software. There's only so much time. So you'll see a head of QA, a head of development, with a bunch of developers in a room and a bunch of testers in a room going through the bug list. You know, we've got priority. No, we don't have priority yet. We've got severity, significance, all these things. And what the team will do is they'll start assigning priorities to it. Basically, all these bugs aren't actually tasks yet. They become, oh, this is like a sprint backlog. It's like a product backlog. Again, we're done writing features. Now we're on to fixing bugs. We've got this long list of bugs. How much effort do we think they're going to be to do? And what's the priority order? So based upon all that information, now triaging becomes, what's the priority order? What is the highest priority, the lowest priority? And now let's fix these bugs in order of priority. That's triage. It's not a pleasant meeting. It's an important one. It's so much better just to avoid ever getting there and having better engineering practices where we catch the bugs early and we don't have to go through these phases. But that's a very traditional thing that happens if you've let your quality drop too low. You're going to have to go through sort of this debug stabilization phase to get it done. What does this tell us, by the way? This is one of the things that we need to know is that every bug fix or every bug found shows the inadequacy of our testing. So bug fixes really should result in new tests that would have caught the bug. So testing didn't catch the bug. That means the testing is inadequate. We can go fix the bug, but how will we know that we don't reintroduce the bug at some other time in the future by accident? We need a test to verify that that has really been fixed. So bug fixes should come along with additional tests. And the test shows that we've really fixed that bug, and great, we're all good to go. And now we'll know if we ever regress, because that test will catch that reintroducing of that bug. Okay? Which really brings us to this last piece of advice. It's the last thing in the book, Dynamics of Software Development. And it's the rule, which is don't shake the jello. Okay, what in the world does McCarthy mean by this? The reality is that changes, which come in the form at the end, in the form of bug fixes usually, often bring with them more bugs. So every single time we touch that product, the idea is it's like you've got that, it's got this jello or gelatin, whatever you want to call it, on your table. And every single time that you change your code, your product at all, it's like giving it a little shake. And the jello starts to vibrate. Now, I often think of it as don't shake it too much, because you might actually cause it all to break and fall apart. But that's not really his metaphor. It's every little time that you change it, you cause it to shake. And then it wobbles back and forth, until it stops wobbling. And it's like, whoa, stopped wobbling. And now it's time to ship that software before we screw it up again. And so you want to enter this mindset, really, that, it's in like capital letters, I warn you, and you'll want to be this way as well. Beware of the small change. This has torpedoed numerous projects. I see it every year in 342. Everyone has worked really hard. They've fixed lots of bugs. They feel like it. We've got the jello. It's not shaking anymore. We're all ready. And then someone, before the sprint review, goes, oh, you know what? Like, I think we should just change the header here to be something like this. Or, oh, I noticed a small little thing. And they go, and they very quickly, they boom, they do their PR. They have their friend really, yeah, please, come on, we got to approve this. We got to approve it right away. Go. They do it. They deploy it. They go to demo it. And it's broken. Beware. You, in the final phases of stabilization, no one should be allowed to make changes without people really thinking about it. Certainly there's going to be new features and things like that, but bug fixes have to be done carefully. And thankfully, you guys are building all sorts of tons of automated test suites, so you're actually able to catch a lot of things automatically that might go wrong. But your tests aren't perfect. They're not fully covering everything. So you got to really be careful, because every time that you touch that product, you set it in motion again. It's wiggling, and you want it not to be wiggling. It's you want to know that there are no more bugs than you actually know that are in there. You don't want hidden bugs that are going to surprise you. All right. This also calls into the need to be vigilant with the daily build, deploy, and smoke tests. This is not a time to let up on that. Okay. Now, not only tests, but all your tests. So any of your tests, if one fails, so if you have a test, an automated test, especially it fails, don't you dare just say, let's skip it. You put a skip in there, mini test, won't pay attention to it, we'll skip it. We won't flag it as an error anymore. Or you might be like, I know people might be looking to see if we skip tests. I'll just simply remove the assert. That's failing. Or you might even remove the whole doggone test to have it pass. Don't do that. What good does it do you to like, the smoke detector is blaring and you're like, shut it off. When there's a real fire, you're gonna die. Don't do that. Your tests, whether they're smoke or other tests, are there to alert you to a problem. Doesn't work to be papering over them, okay? You really need to figure out what the problem is, log the proper bug, fix it, or if you've got automatic tests that are failing because you're trying to check something else in, you probably shouldn't be checking in the other stuff. You got to be really, really, really careful about that. All right. So those are the natural milestones, which lead us up, if we've got sort of the technical debt and quality debt, basically, that we're going to need a debug and stabilization phase to catch up and bring that product back up to the quality standards we expect it to be. We don't want to have to do these sorts of things, but they're going to be necessary if our team has not been able to keep the main branch free of errors. And as you then work to get rid of these bugs, you're always at risk of adding new bugs, because every time you change it, you cause the system to move because you're shaking the jello. So don't shake it. You got to enter into this mentality of very carefully checking each other's work, very careful to make sure that we get this product and it's in a working state. All right, send it to the customer. All right, great, customer has it. Now we can start working on the next version, the next sprint, whatever it is. Whew! All right, very good.